Hi, welcome back. We have here our the general heat conduction equation in rectangular coordinate system. And if there is time that say you can simplify your uh, your condition, say you have a perfectly insulated side, say for example the heat only flows on one direction, let's say at x alone, so you can easily cancel this uh, q along x, I mean q along y and z, and so on. So you can simplify this by having some assumptions and condition. Okay, so in summary, we have the rectangular coordinate system, right? And we have here our equation. So if we treat the k as constant, then we have these expressions, this equation. Okay, so we have the um, have here k as constant. So like what I have said, say for example we treat the heat only flows at x direction, so we can disregard these two and we can come up with this simplified equation along um, x only. So let me rewrite this part here in our summary table. So we have partial derivative of the k dt dx with respect to x. Okay, and then plus the heat generation equal to rho c dt dt. Okay, so that is if we have a constant k, and if we have a variable k, then we can express this as like this. Okay, so we can divide both sides by k. Okay, and once again, if we're gonna consider the flow of heat is in one direction, say for x alone, then we can have our equation as the partial derivative of the partial derivative of t x with respect to x, right? Then we're gonna disregard this plus g all over k rho c all over k dt over dt, and you can simplify this by having the or by writing as it's the second derivative of t with respect to x plus this heat gen is equal to this part wherein, if we recall in our last videos, we have the what we call the thermal diffusivity, right? If you remember, our thermal diffusivity, which is one of the important thermal properties, then our thermal diffusivity denoted by alpha is equal to K all over delta C or Cp, right? So what did you notice? So this part here is actually the exactly opposite, or 1 over A of this term. So we have delta C all over K, I mean rho C K, right? Therefore, this rho C all over K is equal to 1 over alpha, 1 over the thermal diffusivity. So we can substitute this, and finally we can have this expression 1 over A dt over dt, right? So this is for a expression for 1D. And of course, if you have a situation that it involves two dimensions, then you only add this part. And if you have a three-dimensional problem, then use these three expressions here. Okay, but for some what do you call this, some summary of this um, equation, uh, let's have a expression in terms of 1D. Okay, so that's it. Remember that if you have constant k, you can express like this, and if we have a variable k, meaning the k varies, so we can express this using this term. Okay. So aside from this rectangular coordinate system, we also have the cylindrical and spherical coordinate system. So for the cylindrical coordinate system, following the same uh, following the same concept of calculation, but in terms of the cylindrical one, then we can express this expression or equation, and we will have a 1 over r, which is r is the radius, the partial derivative with respect to r of r k dt over dr plus heat generation is equal to this term, rho c dt over dt. Okay, so if we have a variable k, then following the same concept, so we have 1 over r d of r dt over dr plus the heat gen all over k is equal to 1 over alpha delta t over dt. And for um, spherical coordinate system, we can this expression will now become 1 over r squared delta, derivative, partial derivative of this r squared k dt over dr, that is, this is r, plus the heat gen is equal to rho c delta t over dt. Okay, and for if we have a variable k, then we have 1 over r squared partial derivative of this expression with respect to r plus the heat gen over k is equal to 1 over alpha dt over dt. Yan. Okay. So once again, if we have a 3D, then use the heat going in and out of the system at x, y, and z. Okay. So whichever your problem leads you. Okay, and then if no heat gen, then you can cancel this out. Also, if you have no uh, I mean stored energy here, then you can also cancel this out. Okay, so it depends upon your situation and your assumption of your given problem. Okay, so all in all, this is the uh, summary of the equation for rectangular, cylindrical, and spherical coordinate system. So this is for the equation for the what do you call this, the heat conduction.